Hello everyone, hope you all are good. Welcome back to your own mathematics channel asm.geniusjunction. In today's video, we are again going to cover up Unit 1 Algebra. This is your video number 2. Before starting with this video, I suggest you all to please go through with video number 1 so that you can understand the topics covered in this video in a more effective manner. Yes, so the topics which will be covered in this video are solving modulus inequalities, and the second one is division of the polynomial. Okay, so without wasting time, let's start. The first topic, solving modulus inequalities. Whenever we are having a modulus inequalities, there will be two very important properties which we need to understand before solving the modulus inequalities. Property number one says that if we are having a mod of a function and it is less than or equals to a constant, then when we open up the function, the value of the function lies between the positive and negative of the constant. Let's say for an example, suppose if I write mod of x is less than equals to 2, then it means that x lies between -2 and +2. This is your property number 1. Second property says that modulus of a function a is greater than equals to b, then we say that a is less than equals to b or a is greater than b. Okay, greater than equals to b. It depends. If there is a greater than equals to sign, we will use greater than equals to. If there is only greater than sign, of course there will be only a greater than sign over here also. So by using these two properties, we are going to solve the modulus inequalities. Let's start with the solution part of the questions. The first question which is there on the screen will help you to understand how to solve modulus inequalities in a very effective and easy way. Let's start. So this is your question number 9 in continuation with video number 1. So this question says that you need to solve mod of 2x minus 5 less than 3. Okay. So when I'm going to solve this, I will use property number 1. So property number 1 says that the value of 2x minus 5 lies between plus 3 and minus 3. Okay. Now solving this inequality, I will add 5 in inequality. When I will add 5 in complete inequality, I will get 2x on this side less than 3 plus 5 will become 8, and minus 3 plus 5 will give you 2. So I can see that 2x lies between 2 and 8. Now I will divide inequality by 2. When I divide the inequality by 2, I will get x less than 4 and greater than 1. And hence this is the final answer for the given question. Right? I hope you all understood this thing. It's a very simple and effective way of solving a modulus inequality. There can be a question in which they can ask you to solve this modulus inequality by drawing the graph as well. So by using graph, we need to understand how we can solve this. So using graph. So when I will say using graph, I will plot the graph of y is equals to mod 2x minus 5. For this, I will draw a table. Then I need the value of x to be kept equals to 0. When I will put x is equals to 0, I will get to 5. Y is equals to 5. Similarly, when I will put y is equals to 0, I will get x is equals to 5 by 2. Okay. And now there can be any other point. So I can say that I can put x is equals to 4. When I put x is equals to 4, that become 2 times 4 is 8. 8 minus 5 is 3. I can easily plot these values on the graph. So this is your x and y axis. Okay, so let's take the values. 0 comma 5. So let's take it as 1 2 3 4 5. So this is your 0 comma 5 value of first point. Next one is 5 by 2 comma 0. So 5 by 2 is actually 2.5. So I can say that it is 1 2 3 4 5, and point lies between 2 and 3. So this is my point number 2. Okay, 4 comma 3. So this is 1 2 3. So this point lies over here. I will quickly draw the graph. So this is going to be the graph of the given question. Yes. So in this way, we are able to understand how we draw the graph. So right hand side part says that y is actually equals to 3. So we can easily plot the graph for y is equals to 3. So y is equals to 3 is going to be a straight line which will pass through like this. Okay. Now question says that 2x minus 5 mod is less than 3. From this point to this point is my solution region. Why I am saying this? Because between these two values, the graph of y is equals to mod 2x minus 5 is below the graph of y is equals to 3, right? And since we have solved this question in part 1, we can say that these values are going to be 1 and 4. Okay, so value of x is 1 and value of x is 4 for the given question. I can say from the graphical solution, x lies between 1 and 4. So again, this is the solution. This time it is done graphically. In the first part we had done it algebraically. In both the ways we have got the same answer, right? Let's move on to the next level. Now in this part, we are going to use the strategy which we have discussed in video number 1. Okay, so again, as I said that these videos are always connected. So in case if you are stuck somewhere in video number 2, please watch video number 1. You will be able to understand how and the way we are using the properties to solve the questions. We are having a modulus on both the sides. Strategy number 2 says that we will square on both the sides. So I will square both sides. When I will square on both the sides, I get 2x minus 1 whole square greater than equals to 3 minus x whole square. Let's quickly open up the brackets. This is now very simple question. So I will say this is going to become 4x square minus 4x plus 1 greater than equals to 9 minus 6x plus x square. I have simply used a minus b and whole square. Shift everything on the left hand side. This is 3x square plus 2x minus 8 gives you 0. Factorize this by using middle term splitting method. We will get 3x minus 4 and x plus 2 greater than equals to 0. Right? By solving this, I will be getting two answers. One is going to be x is equals to minus 2 actually. And the other answer is going to be x is equals to 4 by 3. Okay? Now both the factors are greater than 0. This is possible only if both of them are positive or if both of them are negative, right? So I will say that my final answer is going to be x less than equals to minus 2 or x greater than equals to 4 by 3. Okay, because at these two values either both of them is going to be positive or both of them going to be negative. So this is the final answer for the given question. In the same way, we are going to proceed for the next question of this video. Yes, so please go through with this particular question and try to understand how we are going to solve such type of questions. Again, this is a very interesting and very good level question. because maximum number of times students get stuck when we need to solve such types of questions. Yes, so now we will solve question number 11, solving modulus of mod of 2x plus 1 plus mod of 2x minus 1. Both of them are having their values greater than 5. We can see there are two mod functions involved in this question. So this question becomes very important. Okay. So yes, so now we will try to understand the point at which these two functions changes their sign. So let's quickly try to understand. If I put 2x plus 1 equals to 0, I can get x is equals to minus 1 by 2. And exactly same way, if I put 2x minus 1 equals to 0, I will get x is equals to 1 by 2. Okay, so basically the critical values are minus 1 by 2 and plus 1 by 2, where the signs of these functions are changing. Okay, so let's quickly plot the graph to understand the scenario in a best effective way. Yes, so this is your x-axis, this is your y-axis, and now we will discuss how we are going to solve this question. When I say that I will be taking all the values of x which are less than 1 by 2, minus 1 by 2, I am plotting these values on the graph so that we can understand it in a best way. Let's say this is minus 1 by 2 and this value is plus 1 by 2, right? So when the value of x is less than 1 by 2, obviously mod of 2x plus 1 is going to be negative, is going to open up with the negative sign. So I will can cite that it is minus 2x plus 1, and mod of 2x minus 1 will also open with a negative sign. So I can write it is mod of 2x minus 1. Okay, so when I solve both of them, this is going to give me minus 2x minus 1 minus 2x plus 1. Overall we will get minus 4x. This is your very important part. So we have discussed that when x is less than minus 1 by 2, I get my answer as minus 4x. Similarly, when x is between minus 1 by 2 and plus 1 by 2, right? When x is between minus 1 by 2 and plus 1 by 2, so obviously this one is going to open with a positive sign and this one will give you a negative sign. Okay, so when the value of x is between these two values, I can write then y is equals to, or the left hand side becomes y equals to 2x plus 1 minus 2x plus 1, and I will get my final answer as 2. So basically between these two values I'm getting my final answer as y is equals to 2. Okay, this is my point number 2. Again, when x is greater than 1 by 2, when x is greater than 1 by 2, obviously both of them are going to open up with a positive sign. So y becomes equals to 2x plus 1 plus 2x minus 1. Total overall I get y is equals to 4x. Okay, so after 1 by 2 I am getting something like y is equals to plus 4x. Before 1 by 2 I am getting y is equals to minus 4x. It means before 1 by 2 I am getting y is equals to minus 4x. After 1 by 2 I am getting y is equals to plus 4x. Between these two values I am getting y is equals to 2. Okay, so my graph is going to appear like this particular line is y is equals to minus 4x, and this particular line is representing y is equals to plus 4x, right? So let's quickly complete the graph of this given question. So this is your y is equals to 2 between x and y axis, between plus and minus 1 by 2. After that the graph goes like this on both the sides. Okay, now comes a very important part. Which one? Let's understand this. Yes, so now we are going to solve the right hand side part, that is y is equals to 5. And if I plot the graph of y is equals to 5, this is 0, this is 1, this is 2, this is 3, 4, and let's say this is 5. So I can draw a line like this, and this line is representing y is equals to 5, right? So this particular point is representing y is equals to 5. Now I need to find the point of intersection with the green line. Okay, so when y is equals to 5, I can find out the critical values. So I will put 4x is equals to 5, and I will get x is equals to 5 by 4. And this is going to be the value of this one. So because y is equals to 4x is on this side, y is equals to minus 4x, this is the equation of this green line. Okay, and this is the equation of this green line. So this is x is equals to 5 by 4. I will put y minus 4x is equals to 5, and I will get x is equals to minus 5 by 4. So my critical points for this question becomes minus 5 by 4 and plus 5 by 4, right? So my final answer for the given question says that the graph of these two modulus functions is greater than 5 when I am on this side or on this side. Why I am saying this? Because at this point and beyond, on the left hand side of this point, the graph of green color line is above y is equals to 5. Same on this particular side. If I move on the right hand side, then the graph of modulus function is above the graph of y is equals to 5 line. So my final answer is going to be x is less than minus 5 by 4, or x is greater than plus 5 by 4. Okay, so this is the way we need to solve these types of questions. Let's move on. Yes, so now we have reached on the topic division of a polynomial. Division of a polynomial is again a very important topic. Why I am saying very important? Because it is scoring, and every time there is a question from this particular topic in the examination, right? If we pay slight attention on this particular topic, we can easily crack the question coming from this topic. A general polynomial can be represented by p of x equals an x to the power n plus an minus 1 with x to the power n minus 1, an minus 2 with x to the power n minus 2, and so on till I get a0. Okay, in this particular expression, I can say x is representing variable, n is representing a non-negative integer, an minus 1, these are representing coefficients, an is termed as the leading coefficient, and the last term, which is not having a variable with it, is actually constant term. One very important point: the highest exponent of x is called degree of the polynomial. So I can say this particular polynomial is having a degree of n, right? So degree of polynomial means highest exponent of the variable, coefficients are there, leading coefficient is there. Okay, let's move on. First question from this particular topic says that divide x cube plus 2x square minus 11x plus 6 by x minus 2. Okay, so let's quickly solve this particular question. I will write x cube plus 2x square minus 11x plus 6. Okay, and we are going to divide this with x minus 2. Okay, this is my rough space. I will be in need of it. Yes. Okay, so this is the rough space which we are going to use. Again, this is going to be very important for us. I need x cube and I have x with me. So my multiplying factor is going to be x square. I will multiply the complete equation with x square. So I will get x cube minus 2x square. We need to change the sign because we are doing division. So we get minus x cube plus 2x square. After changing the sign, x cube gets cancelled and we are having 4x square minus 11x plus 6. In step number 2, I need 4x square and I have x with me. So I need to multiply it with 4x. So I will write it 4x over here. I will multiply it with 4x. I will get 4x square minus 8x. Again, there will be a change in sign. 4x square getting cancelled. This becomes minus 3x plus 6. Now I need to multiply minus 3x by 3. So this is minus 3. So my multiplying factor is minus 3. This is going to give me minus 3x plus 6. Change the sign and you can see I'm getting 0. Okay, clear? So the question was saying apply long division method. We have done the long division method. Now we are talking about first part, that is remainder theorem. Remainder theorem. Remainder theorem is actually a way of finding out the remainder without performing this complete long division process. Yes, without performing this long division process, we can reach what is the final remainder for the given question. So, in this particular question, if I put x is equals to 2 in p of x, suppose if I put x is equals to 2 in the complete function of p of x, I get 2 raised to power 3 plus 2 times 2 raised to power 2 minus 11 times 2 plus 6, and it's going to give me 0. So remainder theorem help us to find out remainder without performing long division method, right? Okay. Now there is a second part of this question as well, which says factor theorem. What is factor theorem? When we see that remainder is equals to 0, when we see that remainder is equals to 0, then divisor, the polynomial by which we are dividing, so remainder if it's 0, then divisor is a factor of p of x. Okay, remainder theorem and factor theorem are well connected with each other. Remainder theorem help us to find out what the remainder is going to be. Factor theorem is just an extension of remainder theorem because it uses the concept of factor remainder theorem. Factor theorem says that if remainder is 0, then the polynomial by which you are dividing the other polynomial is a factor of it. And this goes vice versa. If remainder is 0, divisor is a factor. If remainder is not 0, then divisor is not a factor. Right, my friends? Please pay attention when you are dealing with the questions in examination. Yes. So now there is one more question. This is your 13th question in a row of video number 2. This is in continuation with video number 1. As I already discussed and told to you, please watch both the videos to understand the things in the best possible way. So let's start with the solution. Question says that use algebraic division to show that x minus 2 is a factor of complete expression. So I can say that if x minus 2 is a factor, if x minus 2 is a factor, then in the polynomial if I put x is equals to 2, it should be 0. Let's check. Okay. So what we are going to do, I will put p of x is equals to 2. This is 2 times 2 raised to power 3 plus 7 2 raised to power 2 minus 43 times 2 plus 42. This is 8 times 2 is 16. This will give you 4 times 7, 28 minus 86 plus 42. Let's check. Are you getting the final answer as 0 or not? So this is 28 and 42 will give you 70. This is 86. So you are getting plus 86 minus 86, that is 0. So I will say yes, x minus 2 is a factor, right? In the next part, he wants you to factorize this complete expression completely. Okay. Okay, so let's divide this complete expression with polynomial x minus 2. So this is our polynomial. Let's take this to the next page. Okay, call question is pasted. Yes, so we will be dividing this complete expression with x minus 2. So I will write x minus 2 on this side. On the other part side, I'm going to get my quotient. Again, this is my rough space. One by one, I will try to note down the things. In the first step, I need 2x cube and I have x. When I reduce both of them, I get 2x square. So I write 2x square and I multiply this complete expression with 2x square. I will get 2x cube minus 4x square. Change the signs. This is minus, this is plus. So we get these two terms getting cancelled. And this is going to become 11x square minus 43x plus 42. In step number 2, I need 11x square and I have x with me. So I'm multiplying complete expression with 11x. This is 11x square minus 22x. Again, change the signs. First two terms will get cancelled. Yes, so now I am getting minus 43x and plus 22. So this will going to give me 1 and 2. So that is 21x. Sign is going to be my negative. This is plus 42. Again, step number 3. I need minus 21x and I have x only. So I am having multiplying factor of minus 21. I will multiply it with minus 21 and I will get minus 21x plus 42. Change the signs, you will get 0. We knew that we are going to get 0 because it is a factor. Okay, and we are having a quotient right here. So let's quickly factorize the quotient. So quotient is 2x square plus 11x minus 21. Let's factorize this. So I need two numbers whose product is 42, and when I add them I can get 11. So I can write it over here. I need product equals to minus 42 and sum equals to 11. So it is 14 threes are 42. So now we need to factorize this quotient, and we need two numbers whose product is minus 42 and their sum is 11. So two numbers are going to be plus 14x minus 3x, because 14 times 3 is 42, and minus 21. Let's take out 2x common. This is going to give you x plus 7 minus 3 common. It is again x plus 7. Finally, I'm getting x plus 7 and 2x minus 3. So, therefore, three factors are x minus 2, x plus 7, and 2x minus 3. Answer for the given question. Right? Please pause the video and note down the solutions of these questions. The complete notes and the PDFs are attached with these videos in the comment sections. Please scroll so that you can get the maximum information. Thank you all for watching this video. In the next video, which is going to be the last video of this topic, we are going to cover the factor theorem and remainder theorem in detail. Please don't forget to subscribe, like, and share the video so that you can get the timely information about the videos of AS level and A level mathematics. Thank you so much.